Hey guys, I'm going to do your Unit 7 review with you now, and we're going to do two separate videos, one for solving quadratics and then one for solving rational and radical equations. So let's get started. So we'll start with solve by factoring. In order to solve this by factoring, I want to get everything on one side, so I'm going to move this over to the left. So I'll have p squared minus 11p plus 24 equals 0. Okay, so now I'm looking for two numbers that multiply to make 24 and add up to negative 11. And those two numbers are negative 8 and negative 3. So my factored form, and since I have a lead coefficient of 1, I don't have to factor by grouping. I can go right to factored form. P minus 8 times P minus 3 equals 0. And from there I can get my two solutions. P equals 0. P equals 8 and P equals 3. Okay, so it's what makes this factor equal to 0. So 8 minus 8 would be 0. And what makes this factor equal 0? 3 minus 3 would make 0. Okay, now this next one has a lead coefficient that is not 1. So on this one, I am going to factor by grouping. So first, I need to know what I have to multiply to and what I have to add to. We have to multiply to the product of 5 and negative 8, and that number is negative 40. So we have to multiply to negative 40, and we're going to add up to 18. Okay, so numbers that multiply to negative 40 and add up to 18 are 20 times negative 2 and 20 plus negative 2. Okay, so to factor by grouping, we're going to rewrite this as 5m squared plus 20m minus 2m minus 8 equals 0. So all of this really just took this 18 and split it up into 20 minus 2. Okay, so I'm going to factor out the GCF of each of those two groups. The GCF of this first group is 5m, so 5m, and then divide these two terms both by 5m, and you're going to get m plus 4. Okay, the second group, I need to factor out this sign. This sign is a minus, so I need to factor out minus, and the GCF is 2. So divide both terms by negative 2, and I'm going to get m plus 4. So my factored form is 5m minus 2 times m plus 4 equals 0. Okay, so I need to know what's going to make each of these two factors equal 0. So I'll set this first factor equal to 0. 5m minus 2 equals 0. I'll move that 2 over. 5m equals positive 2. So m equals 2 divided by 5. Okay, now what makes this factor equal to 0 is a little bit easier. It's negative 4. Negative 4 plus 4 is 0. So my solutions are 2/5 and negative 4. Okay, and last in this section, I'm going to move this minus 4p to the left side, so I'll get p squared plus 4p equals 0. Looks like with this one, all I can do is factor out the GCF. The GCF of these two terms is p, so p times p plus 4 equals 0. And from there, I can go right to my two solutions. What makes this factor equal to 0 would be if p equals 0. And what makes this factor equal 0 is if p equals negative 4. Okay, next up, factor by taking square roots. Okay, so to take square roots, notice I have an m squared term but not an m term. So I'm not going to get everything to one side this time. I'm going to move this negative 1 over. So I'm going to add 1 to both sides. Negative 9 plus 1 is negative 8. So m squared equals negative 8. and then I can take a square root. So m squared is plus or minus the square root of negative 8. I'm going to do a factor tree on that negative 8. And first I'm going to start with it's negative 1 times 8. 8 is 4 times 2. 4 is 2 times 2. So I've got a negative 2 that's going to come, I've got a 2 that's going to come out. I've also got a negative 1 that's going to give me an I. So my answer is m equals 2I times the square root of the leftovers, which is just 2. And that should be plus or minus 2I root 2. Okay, this one is ready to take a square root in my first step. So I get 3x minus 2 equals, and for the square root of 25, that's plus or minus 5. Okay, so now I can add this 2. So that's going to look like this. 3x equals 2 plus or minus 5. And then I'm going to divide by 3. So I've got 2 plus or minus 5 divided by 3. So I need to solve two things now. 2 plus 5 divided by 3. So x equals 2 plus 5 is 7. Divided by 3 is 7/3. And then 2 minus 5, which is negative 3, divided by 3, which is negative 1. Okay, next up, solve by completing the square. So in order to complete the square, I need a lead coefficient of 1, which I have. I also need to get rid of this c by moving it to the other side, so I'm going to add 50 to both sides, and I'm going to make room for a new c. N squared plus 8n, and then a blank for my new c, equals negative 5 plus 50, which is 45. And a matching blank, so one on each side. In order to fill in that blank, I need to do b divided by 2 squared. b is 8, so that's 8 divided by 2 squared, which is 4 squared, and that's 16. So plus 16 on both sides. Okay, next up is the factored form. What multiplies to 16 and adds to 8? That would be 4 and 4. So it's going to be n plus 4 times n plus 4, which is the same as n plus 4 squared. Okay, little shortcut. I have that number right there. It's always going to be this number I get after doing b divided by 2, but before I square it. So I can take that 4 and put it right there. And then 45 plus 16, and 45 plus 16 is 61. Okay, so now I'm going to solve by taking a square root. So square root of both sides, and I get n plus 4 equals plus or minus the square root of 61. And I'm going to move that 4 right there, and it's going to become negative going to the other side of the equal sign. So n equals negative 4 plus or minus the square root of 61. And last in this line, solve with the quadratic formula. In order to do that, I need to set it equal to 0. I've got to move that 50 right there. So I've got 6r squared minus 5r minus 50 equals 0. So as I put that in the quadratic formula, it's r equals the opposite of b. So b is negative 5. Opposite of b is positive 5. Plus or minus the square root, and I'll write in my radical later, of b squared, so that's negative 5 squared, minus 4 times a, which is 6, times c, which is negative 50. And there's my radical, all over 2 times a, and a is 6. So I need to find out what goes under that square root. So I'm going to bring the calculator over, and we've got negative 5 squared minus 4 times 6 times negative 50. So underneath that radical is 1,225. Okay, and that is all over 2 times 6, which is 12. Okay, so next I want to take the square root of 1,225. So it's 5 plus or minus, and let's see if that's a square number. So second square root of that previous answer is 35. Okay, so I've got 5 plus or minus 35 over 12. Okay, so we've got 5 plus 35, which is 40, over 12. And we've got 5 minus 35, which is negative 30, over 12. 40 over 12. So what goes into 40 and 12? I think 4 is going to be the biggest number. 4 goes into 40 10 times and into 12 3 times. So I'm going to get R equals 10 thirds. And then negative 30 and 12, I think 6 is going to be the biggest. That goes into both of those. So that's going to be negative. 30 divided by 6 is 5. 12 divided by 6 is 2. So 10 thirds and negative 5 halves are my two solutions. Use the discriminant to determine the nature of the roots. The discriminant is b squared minus 4ac. Okay, so that's this part of the quadratic formula right here. Okay, so b squared minus 4ac is 6 squared minus 4 times 3 times 3. Okay, so that's 36 minus, and then 4 times 3 is 12, times 3 is 36, and that gives me 0. So in the quadratic formula, if I have a 0 underneath the radical, that is going to give me one real solution. Now, if I was to get a negative underneath that radical, anytime you have a negative under the radical, you're going to have imaginary solutions with the letter I. So if your discriminant is negative, you're going to have two imaginary solutions. If this number under here is positive, then you are going to have two real solutions. If it's 0, you have one real solution. Okay, last up in our quadratic section, a ball is thrown downward from a height of 135 feet, initial velocity 28 feet per second. How long will it take to reach the ground? So here's our equation. H is the height, 1/2 times g, which is acceleration due to gravity, and on Earth, that's negative 32.2 feet per second squared. T is the time that it's in flight. V sub 0 is the initial velocity, which here is 28 feet per second. H sub 0 is the initial height, which here we're told is 135 feet. Okay, so H is the ending height, and the question is, how long will it take to reach the ground? When it's at the ground, the height is 0. Okay, so for height, we're going to put in 0. Okay, so equals 1/2 times g, which is gravitational acceleration, negative 32.2 feet per second squared. And then t, that's time. That's the question. How long will it take? So t squared, we don't know t yet. V sub 0 is 28 feet per second times time. And h sub 0, the initial height, is 135 feet. Okay, so let's multiply 1/2 times negative 32.2, so that's 0.5 times negative 32.2. negative 16.1. So 0 equals negative 16.1 times t squared plus 28t plus 135. To me, it looks like the easiest way to solve this one is going to be the quadratic formula. So we've got t equals opposite of b is 28, opposite is negative 28, plus or minus b squared, so that's 28 squared, minus 4 times a, negative 16.1, times c, 135. And that's under a square root, all over 2 times a, 2 times negative 16.1. Okay, so let's simplify a little bit. Negative 28 plus or minus the square root of 28 squared minus 4 times negative 16.1 times 135. So that's 9,478. So we've got the square root of 9,478, and that's all over 2 times negative 16.1, which is negative 32.2. So we've got t equals negative 28 plus or minus, and then we'll do the square root of that number. So square root of the previous answer is 97.36. And that's all over negative 32.2. Okay, so now we need to solve two expressions, so this with a plus and then with a minus. Okay, so we've got negative 28 plus 97.36, and then we're going to divide that by negative 32.2, and we get negative 2.15 seconds. Okay, now that number doesn't really make sense, but we're going to make note of that anyways. That's one of the solutions. Then once with a minus, so negative 28 minus 97.36 divided by negative 32.2, and we've got 3.89 seconds. So our two solutions are negative 2.15 seconds and 3.89 seconds. Okay, a negative amount of time does not make sense, so we're going to have to throw out that negative solution. So our time is 3.89 seconds.